It feels like just a second ago that we were starting this thing, and somehow we're already on week 6, day 4. We are heading into the final section with the capstone project, and let's make sure that we end this thing in style. This is going to be a great project. Welcome to the capstone project. Welcome to autonomous trading. We are going to build agents that can make their own decisions about analyzing financial markets and that can make trades in a synthetic account that we have created ourselves in week 3 with our other team of agents. Okay, so autonomous traders then. Let me tell you a few things about the project that I have in store for you. So first of all, it's something that is commercial. One of the things that I've noticed about a lot of the modern agentic AI projects is that they're quite technical in nature because they're so open to possibilities that one tends to build things like teams of coders and stuff like that. I really wanted our capstone project to be something that showed how you could apply it to a true commercial problem like analyzing and understanding financial markets. And that's why I've gone in that direction. It's going to involve having 5 different MCP servers with tools and resources, and we will count them up, and there's going to be a lot of them. Look forward to it. There's going to be interactions between agents, and there's also going to be autonomy in this. We're going to allow our agents to choose their own adventure. They're going to be given the freedom to make various decisions themselves. And then, most importantly, something that I may say once or twice, please don't use this for actual trading decisions. This is something which, yes, I don't want to get in trouble if you go and put all of your life savings into this. This is, of course, an experimental project and nothing more than that. Having said that, of course, if you make a massive fortune on this and you're off sailing in your yacht, then I do expect an invitation. But no, do not use it. Do not get your yacht this way. Get your yacht by building autonomous agentic solutions for people, not by having your traders run amok with financial markets. Anyway, with that introduction, we're going to spend most of our time sleeves rolled up in code, and let's get started now. Okay, here we go. Back in Cursor, we're going into the folder for 6, and we're going into Lab 4, our Autonomous Traders project, an equity trading simulation to illustrate autonomous agents powered by tools and resources from MCP servers. Okay, so we are going to create a simulation. We are going to have 4 different traders eventually, and 1 researcher. Actually, each trader will have their own researcher powered by a bunch of MCP servers. We're going to have our homemade accounts MCP server that you remember that we did in the second day. We will use fetch that we used in the first day. We'll use memory. We'll use the SQL-based relationship memory that we looked at. We'll use the Brave search, and we'll use the financial data courtesy of Polygon.io. So what we're going to go through now is build this in the lab, and then we're going to look at the code, the module traders.py that will take the same thing pulled together. And it shows you a practice which I like to do, which is to work initially in the lab while you experiment. And it ties to a point that I know I make a million times that I'll make again at the end, which is how important it is to approach agent projects with a data scientist's hat on. First and foremost, be looking to experiment and understand what you're doing, not just jumping straight into engineering and building. It's important to start by investigating and understanding what you're doing. One other thing that's important to do is not use this for trading decisions, if I haven't already mentioned that. So one more warning for that. Okay, let's get going. Let's do our imports and set our .env, and let's look at the Polygon situation. Do we have an API key? And have you said whether or not we are in a paid plan? We are in paid plan for me. You may be false there, and we're not using the real-time Polygon. Okay, what we're going to be doing in the next few cells is collecting together the different MCP server parameters for all of the MCP servers that we're going to equip our model with. So first of all, I've got a little decision here. If we're using any of the paid Polygon plans, then we are going to directly use Polygon's MCP server with its whole set of different tools. If not, we're just going to use that tiny MCP server that I handcrafted in marketserver.py. And that's because if you're using the free plan, we don't want to overwhelm the model with lots of different tools. And there's another reason for it too, which is that here I'm using that trick of caching the previous day's data so that we don't exceed our rate limits with Polygon on the free plan. So that's why we've got the little decision there. And then we're also going to include in our parameters the accounts server. So this is our homegrown MCP server to read and write from accounts. And then there's a new one, push server. I wonder what that could possibly be. Let's just run this, and then we're going to take a quick look at push server. It's another homegrown MCP server. What could it possibly be doing? Let's have a look. Here it is, push server. Push server, of course, is going to send a push notification. You know how I like the push notifications because it makes it feel so autonomous when it's like messaging you suddenly. And so we're going to have it pushing. We're going to arm it with an MCP tool. And this is an example of a case where we're writing this MCP server and we're not delegating on to some business logic. We're just putting all the logic right here in this single Python module. It's an MCP server. It has a single tool. It's called push. And it takes a little pedantic object that we've set up here to say that it is a brief message to push. And that is the message that we give. So this is a clear example of how you can write a little tool and expose it as an MCP server. Now, as I said before, really, there's absolutely nothing stopping you from just having this as a tool. In fact, that would be the better way of doing it. There's no point in having an MCP server like this when we're just using the tool ourselves locally. But we want to get in the practice of making MCP servers, so why not? Okay, so with that, we have now also included our push notification as well as the accounts and the market data as our trader MCP servers. So that set up the MCP servers that our trader will use, but we'll have another agent called the researcher that's able to do market research. And we also want to arm that agent with tools as well. And for that one, we will use the Brave key and we'll give it fetch as well. We'll give it the ability to fetch web pages. And so both of these two together are going to be the tools that we will equip our model with. All right, and now it's going to be time to put these to use. Okay, so we've gathered up our parameters into these params lists. What we're now going to do is create MCP servers. We're going to instantiate MCP servers with each of those params and with the 30-second timeout. And so we do all of that, and we've just built a bunch of these MCP servers ready to go. Okay, so we're going to have two different agents that we're going to define. We're going to have a trader that's able to make trading decisions and a researcher that does market research, and the trader will use that researcher. And you may remember from week 2 in OpenAI Agents SDK that when you want to have that kind of collaboration where one agent uses another, the best way to do it is to have that other agent, the research agent, be like a tool, convert it into a tool so that that agent can just be used as a tool by the trader agent. And that's exactly what we're going to do now. So we start by defining our researcher agent. So here's the system prompt, the instruction. You're a financial researcher, you search the web for interesting news, and then you carry out deeper research and respond with your findings. And we tell it the current date. And you remember I said it's better to do this than to have a tool to look up the date, because you might as well always pass it on and not add extra complexity to the agent to force it to come back and run a tool. So we just provide the current date right in there. And then we pass in, of course, our MCP servers, and that defines our researcher. And then you'll remember this construct. This is how we say we want to use this as a tool. We simply call as tool on that researcher, and we give the tool a name and a description. And that means that this agent will be available for use by other agents that want to be able to treat this like it's a tool. And that is a very common pattern with OpenAI Agents SDK. Well, before we use the research agent as a tool, let's just try calling it directly to check it works. So we're going to ask the question, what's the latest news on Amazon? And we're going to, first of all, go through and connect with all of our MCP servers. Now, you'll notice this is a bit different. Well, I normally have like with MCP Studio as, and then I do it that way with a context manager. So why am I doing it differently this time? Because if you've got a bunch of these, we'd have to have lots of withs all nested, and that would be quite clunky. And so this is just another way of doing it. You should also clean up if you do this, but because we're just running in a Jupyter Lab anyway, it doesn't really matter. So we're connecting to the server here. We're then getting our research agent, and then we're calling runner.run for the research agent, passing in the agent and the question. And this is new. I'm also passing in something called max turns in here. And that's because if the default is 10, which means that it can by default do up to 10 sets of tool calls. But if we wanted to do deep research, we might want it to take longer than that. So we might want to give it up to 30 possible maximum turns. So that's why I'm setting it that way, and it's good to know that that's another thing that you can control. And you can also, of course, have that be a smaller number if you don't want to let your agents go off and potentially get into a loop of overthinking about things. But 30 seems to have done the trick for us, and probably we didn't need anything like that. And we got back a bunch of information about Amazon. Let's go in and look at the trace to see what happened behind the scenes. So if we come in to the trace and we come into the researcher, you'll see that it did a Brave search. It did a bunch of fetching of web pages. It did another Brave search and some more fetching of web pages before responding with its answer. And you should do this and go back and have a look and see what it does and what kind of searching and fetching the agent is doing as part of its research into Amazon. Okay, so now let's look at our trader. So I'm going to start by giving our trader a strategy, because that's something that we store in the account. And the reason that I give a trader a strategy which is stored is that I want traders to be able to change that strategy should they wish. We're going to give each of our traders a unique strategy to set them going, but we want to give them some autonomy to choose to evolve their strategy if they want to. But for me, Ed's initial strategy, I'm going to be a day trader that aggressively buys and sells shares based on news and market conditions. And I'm going to call this reset function to get Ed off to a good start. And let's use these resources to read my account and my strategy at this starting position. So here we go. My starting position is I have $10,000 ready to invest. There is my description. And I have empty transactions and nothing in my portfolio. And everything is ready for business. It's now time to create our trader agent that is going to take this persona and be able to make trades as a result. Okay, so this is our trader agent right here. It's called Ed. And the account details, it's reading in a resource, and the strategy is reading a resource. What is this reading a resource? This is, of course, calling the MCP client that we created ourselves a couple of days ago. It's calling an MCP client that then calls the MCP server that provides the resource by calling our business logic. So it's kind of cool. We're using this resource side of MCP, the fact that you don't just need to use MCP for tools, you can use it for resources as well. And so what does it mean to use MCP for resources? What do you do with these resources? Well, it's just text that you shove in the prompt. You just add it to the prompt to give your agent more context to be able to make its decisions. And that's exactly what we do here. So we call these two resources and then we put together our system prompt. You're a trader that manages a portfolio of shares. Your name's Ed, your account's under your name, you have access to tools to do your job. Your investment strategy is, and then we shove in the strategy from this call here. Your account, your current holdings and balance is, and we just shove in the account details right here. And then we tell it to make decisions based on its tools. So if we run that and we print the instructions, we'll see that when it prints out, we get things like the current holdings and balance included in our prompt. This is our resource. And you can see I'm just shoving JSON in there because LLMs love JSON. It's going to be great with this. It'll make total sense to it. And so with that, we can kick off our trader. So set this running while I speak. So we connect to each of the MCP servers. We then turn our research agent into a tool, and we get our research agent as a tool. We then create our trader agent. We give it its instructions. We pass in as tools, we pass in our researcher tool, which is a wrapper around the agent. For MCP servers, we pass in the full set of MCP servers. We're using GPT-4o Mini in here. You might want to update that to GPT-4.1 Mini if you're looking at that now. And then we call runner.run, and we pass in the trader and the prompt. And again, I'm adding to max turns. I'm not going with a default of 10. I'm giving it up to 30 turns to really go to town and be requesting across things. And now, typically this takes a minute. So I'm drawing out this explanation as long as I possibly can in the hope that it finishes before. And it may well observe that the markets are closed right now, so it can't make trading decisions. It's possible that it will do that, or it might decide that it wants to make some trading decisions anyway, even though the markets are closed. But we will soon find out. So here we go. It's it has decided that it has. We gave it the tool to do it, and so it's decided to do it. It's got a bunch of different summary actions, the results of the research and the trades that were executed, that it bought shares and sold shares, and that's the current portfolio status. And it's got some next steps at the bottom. So that is the result of our trader agent running using the research agent and being able to execute its tools, and also being armed with the resources that we included in the prompt. And I wouldn't be doing my job if I didn't say that we have to go and look at the traces. You always have to go and check out the traces and make sure you're happy with what's going on. And it shows here that this was Ed, the trader agent, going to the researcher agent that we were using as a tool. You can see that about half the time was spent in research mode. It used the tool. That green shows it's using a tool called researcher that's then using our agent. We're listing the MCP tools, and we're then doing a Brave search. We're doing the fetches. This is like before, and that's coming back. We have to press load more because it's such a long thing here. We're then getting some tickers. We're getting the last trades. We're getting some quotes. We're getting some close of market prices. It's doing plenty. It's getting the previous close prices. And then it ends up buying some shares and selling some shares, just like it told us it did. If we click here, we can see that it's bought Disney, and it's also sold 25 shares of Disney. So it's not hugely intelligent of it to buy shares and sell so quickly, but I guess we did tell it that I'm an aggressive trader that likes to buy and sell. I mean, that's super fast to do it instantly like that, but I guess that is what it wants to do. So it bought 50 and then it sold, and then it bought 30 Tesla and it sold 25 of the Disney shares that it just bought. So there you have it. That is our trace that is showing our trader in action. It's showing the collaboration between two different agents, one of them as a tool, and it's showing the use of the MCP servers. Well, let's just quickly look at the results of the trading by reading the resource again using the MCP client. And you can see that I've got less in my cash balance, and that I have my remaining 25 shares of Disney, and that is the various details we have there about what's going on. All right, we're now going to look at some Python modules. Wait, did you spot that intentional little hiccup there? It was just after I stopped recording, I was thinking, and I'm like, hang on a second. We saw that in the traces that it bought Tesla stock, and it didn't report that it bought Tesla stock, and we didn't see that in our holdings at the end. So let's go back and see what happened there. So I went back into the trace and I took a look, and I scrolled down, load more, sure enough, if we get down to the bottom here, you will see that there were indeed these two buying shares. First of all, it bought 50 Disney shares. And then, as I remember, it bought 30 Tesla shares. What's going on? Well, then I scrolled down and saw that it got an error back from this. error executing tool, insufficient funds to buy shares. And what's kind of brilliant about this is that that error message is an error message that was written by our crew agents in week 3. We asked it, one of our business requirements is that it should put something in there that prevents the person from buying more shares than they can afford. And so that error message, insufficient funds to buy shares, was written by those crew agents. That's what's been surfaced back here. And that is why those shares weren't bought, and that's why it didn't include that on its summary, and indeed why although it does mention that it should be monitored in the next steps, and that's why, of course, it isn't in the holdings at the bottom. So there's a great explanation, and everything is working perfectly. So we're now going to go and look at some Python modules, some Python code. And this really brings, again, this very important point that a great way to work with building agentic frameworks or building agentic solutions to business problems is to start in the lab, start in a notebook like this, experimenting with prompts and different agent configurations, and don't move to Python modules until you've done your experiments. I do get a lot of people asking me, how am I going to go about building this agent solution to the following commercial problem? And they want to dive straight into code and building lots of agents, and they want to build a diagram that shows boxes with agents all talking to each other. And I say to them, look, it's super important to begin by experimenting. Wear that data science hat. Start in the lab. Start by experimenting with prompts. Understand what are the capabilities that you can give an agent that it can stay coherent and it can follow instructions, and how can you give the right balance between autonomy and coherence. And these kinds of decisions, they come through practice, and it doesn't come from designing a big picture and then coding for a long time and then kicking it off and then complaining when it doesn't do what you want it to do, because it won't the first time if you do it that way. And that's why the right way to approach this is little by little, starting small in the lab. So that's what we've done here. We've done that. We've been in the lab. We've built something, and it's now time for us to turn this into code. And we're going to do that. And I'm going to show you piece by piece 3 different files: MCP servers, templates, and traders. So first of all, MCP servers is where we define our MCP servers. So here we go. We're looking for, it says MCP servers. It's MCP params.py. Change that right now. MCP params.py is where the MCP servers are specified. So here we go. We're in MCP params.py. Now, you don't need to have your MCP parameters specified in a Python module separate to your other code, but I think this is an organized, tidy way of doing it to keep things nicely, the right concerns in the right file. So in this file, I'm setting up my different MCP parameters that I'll use later when I'm creating the MCP servers. So first of all, for market data, I choose to either use the official Polygon MCP server, or I use the little sneaky one that we made, marketserver.py, that caches results and makes sure that you can use free Polygon IO without exceeding your limits. So we pick one or the other depending on how your .env is set up. Okay, and then the full set of MCP servers for our trader is the accounts server, our homegrown MCP server for accounts, the push server, another little homegrown server sending push notifications, because you know I love them, and then the market server for the market data. Okay, and now we've got a separate set of MCP servers for our researcher. There are 3 of them. First of all, fetch, the ability to fetch a page using Playwright browser behind the scenes. Then we're using the Brave search again, our free Brave search API for web searches. And then this, the return of the memory. We're using our memory, we're using the SQL-based memory. And you can see I'm actually going to try and have a separate memory file for each trader based on its name. So then the name will be passed in, and that's what we will use here as the name of the memory file, so that every trader, every researcher has a separate set of memory. Okay, that is the MCP params module. So the second module I wanted to show you is called templates.py. And here's the thing, templates.py is just where I have put any function which is returning like a prompt instruction or a string or something like that. And I've done this to be organized so that I don't have tons of text coded within the body of my functionality. And again, this is just a nice, good practice. It's good to separate concerns this way. It means that if I need to edit my prompts, I've got one place to go and do it. I've got effectively my prompt templates. In many ways, if you think of some of the more opinionated frameworks like LangChain or like CrewAI for an agent framework, they sort of force you to separate stuff like this. Well, they don't force you, there are ways around it, but Crew, for example, of course, has the YAML files, which specifically takes to one side your text. But we're not using those kinds of frameworks, but there's nothing stopping us from putting us through the discipline of putting all of our text like this into a separate module, and that's why I've got it here. So I've got my researcher instructions, my research tool definitions, my trader instructions, and my prompts all here in these different functions. And you'll see I do things like inserting the current date in the prompts, which I said before was a very good practice to avoid having to equip it with a tool that it needs to call just put the date in the prompt. And you'll also see how I'm putting the strategy and the account details straight in there in the prompt. So that's templates.py that separates out our text into its own module. Okay, and with this, it's time for us to go and have a look at traders.py, the module for defining our traders. And just before I do this, I want to mention that there's some fancy Python I've got in here, which it looks a bit muddling the first time you see it. One of the slightly hokey things about working with OpenAI Agents SDK is that it's good to use the context managers to wrap creating a server like I've got right here, this async with, and then the Server Studio passing in the parameters as a server. But that can start to look super ugly if you have a bunch of servers, which we do, we have many. When you have many, you'd have to have a separate with statement, a separate context manager on each line indented, and it gets a little bit out of control. And there is a Python technique which is quite an advanced technique for not having to have a stack like this, but just being able to do it, sort of iterate over lots of context managers, lots of withs. And it looks like this. And with async code as well, it's a little bit muddling, but you can have with an async exit stack, and then you can do this enter context for each in a list. So this construct that you're seeing here, this code is just taking the MCP server params and iterating over that and effectively doing a with for each of those in turn. So look into this if you wish. It's a construct. I use it to make the code a bit neater, but don't let it put you off. You could equally well just do it the manual way. Okay, so with that little caveat, let's go and have a look at traders.py. This is the module. It's just taking what we had in the lab and turning it into a Python module. There is some cool stuff at the top here that just allows it to switch different models. So we're not only relying on OpenAI. We can use DeepSeek, Grok, Google, or we can use OpenRouter, for Americans. We can use OpenRouter to connect to any model of our choosing. And if you look in the guides directory, there's a whole guide that talks more about this use of different models. So based on which one you choose, it will pick a different model provider. And other than that, this is basically exactly what was in the lab, in the notebook, turned into a class, into a Python module. And just here is that funky stuff I was just talking about with the stacks. So, you know, if you're suspicious of this, then look into it a little bit more, read up about this construct here and why I've done it this way. And if you dislike it, you can always manually have the with, but it will be quite nested. It will look a bit ugly, but it would be a bit simpler to do it that way. But other than that, everything here, it simply involves creating a trader agent and using a research agent as a tool. And it's the same code that we had a second ago, and it's all packaged into a nice class trader so that we can create an instance of trader, giving it a name and an agent and a model name, and off it will go. One other thing about it that's kind of fun is that I did have it alternating between making trading decisions and making decisions to rebalance its own portfolio. So I've given it that ability to either trade or rebalance as it wishes. So you can see here that if the do trade flag is set, then it will run a trade message. Otherwise, it will run a rebalance message, which you can look in the templates, is a message to say you should rebalance your portfolio to be optimized. And at the bottom here in run, this is of course the business function. This is what kicks it all off. It kicks off a run, and then it will switch that do trade flag. It will flip it the other way. So that is the trader module. It's one thing about this I haven't told you yet, which I'm going to tell you about tomorrow. But this is basically showing you all of the stuff, all of the good stuff that we wanted to build around having an autonomous trader that alternates between trading and balancing its portfolio and uses a researcher agent to help it, and using a bunch of MCP tools. Okay, so now back in the lab, let's actually see what this module does. So we're going to import that trader, the class we were just looking at a second ago. We're going to create a new instance called Ed of that trader. So that's now called Ed, and because the name is Ed, it's going to look up in accounts and have access to that same account, the thing that just bought Disney shares and then sold them again, some of them. And now we're going to call the trader.run. This is the business. This is the thing that's actually going to kick it off and run this whole process. Let me get on with it. So I kick that going, and while it's running, we'll let it run for a little bit so it gets started with its activity. We'll open up the trace. Let's see what's happening here. Here it is. And so it's off and running. It's listing tools and it's thinking. We'll see if we can just refresh it like that. Yep. It's doing a Brave web search, and it's now going to take its time over this. So rather than sitting here thinking of what to say for a couple of minutes that will take, I will be right back with you. Okay, well, that just ran and it completed. And the result, it took 48 seconds. It didn't take too long. And it did end up by complaining that one of the tools had an error. So we can go and check that out. But otherwise, it seemed to do its thing. So let's go and have a look at the trace. So we'll come in here. Here we go. So it did listing tools. It starts with the researcher. The researcher does a Brave web search, and then it comes back. And now we're with the trader. It does a bunch of tickers. It does lots of tickers. It does some buying and some shares. What's it bought? It bought Amazon and more, and Apple and Microsoft, and that's great. And then at the end here, it does some selling of some shares as well. Again, I guess because it's so aggressive. Looking to sell some shares, and then it ends with a push notification. And this is where our error happened. It said that there was an error running the tool, which is interesting because that looks fine to me. And it's also interesting because I did actually get a push notification on my phone there. Just check, it does indeed have exactly the same message. So I got the push notification. It came through. It worked fine. I'm not sure why the error appeared here. It may be because that method didn't return anything. So I just changed that just in case. But anyways, I'd say that is a wholehearted success. Our agent just worked fine. And now we can call our read accounts resource and check what happened. And you'll see indeed that we do now have Amazon shares, and we've done a bunch of these transactions, if you look in here, which are consistent with that trading activity. So it looks like things were successful. We've been able to run our trader agent using this code, using our module, and it's called a slew of MCP servers, and it had collaborating a trader and also a researcher to do it. Okay, and finally, before we wrap up, let's just quickly count how many tools we just used in total. So from that MCP params module, we can import the trader and researcher params, add them up, and then iterate through them, and for each one collect the tools and report on the total number of tools that we just made available to our two agents, our trader and researcher agent, in what we just did. And so we had a total of 6 MCP servers and 44 tools. That's a lot of tools. Yeah, that was great fun. And of course, you know what I'm going to say. The challenge for you is that you can add more tools. The more the merrier. We can give more capabilities to our traders to allow them to do more. And of course, if you work in finance, if you have business knowledge of this area, then I'm scratching the surface of what we could achieve with this. And you can add in tons more capabilities than our 44 tools. But again, one more time, I would urge you to start by adding in those tools working in the lab to understand what the model's capable of and to experiment with it before you then go and put it into the modules and run it as part of the final architecture. And that's a wrap on day 4. Obviously, we covered a lot of ground, and it's super important that you go through and replicate this yourself and look at things, look at this code to get a good sense of how you go about building these sorts of agent solutions. And of course, make it your own. As always, tweak the prompts, experiment. Remember, they're all in that one module, templates.py, so you can experiment with changing the prompts and see how that affects the characteristics of the trader. But of course, the big moment is coming tomorrow, and we then unveil the full platform. We put the finishing touches on everything, and there's some really cool finishing touches. We bring it all together, and I also want to give some summaries on big picture thoughts on a big question like, okay, we've covered all these different agent frameworks, so which one should I choose for my project? We'll answer that as well, all in our grand finale next time.